Something exploded on the far side of the sun, and it was a big one. SOHO coronagraphers discovered a bright, halo-like coronal mass ejection. If a coronal mass ejection penetrates interplanetary space, it's called an interplanetary coronal mass ejection. Coronal mass ejections can reach and impact Earth's magnetosphere, where they can cause geomagnetic storms and/or wars, and in rare cases, damage to the power grid. A coronal mass ejection is a massive ejection of plasma and magnetic fields from the solar corona. They can eject billions of tons of coronal material and carry embedded magnetic fields frozen in the stream that are stronger than the background interplanetary magnetic field IMF of the solar wind. CMEs move away from the Sun at speeds ranging from less than 250 km per second to nearly 3,000 km per second. The fastest Earthbound CMEs reach Earth in just 15 to 18 hours. Slower CMEs may take several days to arrive. Their size increases as they move away from the Sun, with larger CMEs reaching sizes that span almost a quarter of the space between the Earth and the Sun by the time they reach Earth. Coronal mass ejections contain particle radiation, mostly protons and electrons, and powerful magnetic fields, stronger than those normally present in the solar wind. These explosions occur in a magnetically disturbed region of the Sun's upper atmosphere, the corona. Researchers monitor coronal activity using coronagraphs, which block the view of the Sun's bright disk and allow us to see what is happening in the Sun's atmosphere. Although the explosion site is hidden and the coronal mass ejection is not coming towards us, the explosion still had an impact on our planet. Satellites orbiting Earth recorded an increase in high-energy particles impacting the atmosphere. The particles were picked up by the expanding coronal mass ejection shockwave and accelerated throughout the solar system. Its ionizing effect has caused shortwave radio blackouts in the Arctic. During the solar maximum of the sunspot cycle, when there are many sunspots on the Sun, magnetic disturbances occur and coronal mass ejections become more common. Most coronal mass ejections form near sunspots. Coronal mass ejections are also often associated with solar flares.